Let's begin. Today's August 26th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 6, 11, 17, 21, and 22. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A looks at our first digit, the triangle digit, and compares it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should it be greater than 3? Criteria card B looks at our middle digit, the square digit, and will let us know whether its value is an even digit or an odd digit. Criteria card C will compare the first 2 digits, triangle and square. So should triangle be less than square? Should they be equal to each other, or should triangle be greater than square? Criteria card D will look at our 3-digit solution and will let us know how many of those are even digits. Are there no evens? Is there a single even? Perhaps 2? Maybe all 3 are even. Criteria card E again looks at our 3-digit solution, but this time will let us know a little bit about its structure, specifically if there's a pair in the solution, as in the example 131, or alternatively, there are no pairs, but there are 2 scenarios, one where all the digits are different, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F looks at the 3-digit solution and will let us know a little bit about the order of the digits from triangle to square to circle. Should they be in an ascending order, meaning that they're increasing, as in the example 135, or are they in a descending order, such as 421, or potentially they could have no order. So let's look at the example 231. Notice that it goes from 2 to 3, it increases, but then it goes from 3 to 1, and then it decreases. It's that shift from increasing to decreasing, or in other examples, it could be decreasing and then increasing, that define it to have no order. Now, there have been other puzzle solutions where if you have 2 consecutive digits, one right after another, that are equal, that is also a case where it has no order, because when you have 2 identical numbers next to each other, there's no change from one to the other. So that is, as stated, another example of no order. And remember, the objective of today's puzzle is to find that one unique 3-digit code that abides by all of the criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I want to do is I want to test criteria card B. Okay, so for criteria card B, we're looking at that middle digit, the square digit, and I chose an odd 1. The Turing machine does not agree with that. So it's basically telling me that square is actually an even digit. So let's go ahead and type that up in our notes. Square is an even digit. And since it is even, that means I can cross out all the odds. So it can't be a 1 or 3 or 5. Next, I think I'll test criteria card E. Okay, so in this case, the Turing machine does approve. Notice that I do have in my proposal 314, there are no pairs, they're all different. So that means that the Turing machine agrees that the solution should have no pairs. So let's go type that up in section E. So at this point, we should be asking ourselves, is it possible that it's a solution where all the digits are distinct, or all of them are the same? So at this point, we really have no indication one way or the other. However, I guess we could probably say the following though. If it is the same digit repeated 3 times, then we would know that there would be no order. And I think that would make this card irrelevant, and that can't be the case. So I'm pretty confident that it should be all 3 distinct digits. And that said, since we do have an even in square, I think I'm going to test criteria card D. Okay, so in this case, the Turing Machine does approve of my proposal. I do have 2 odds to a single even, and the Turing Machine agrees that there should be only 1 even digit. So let's go ahead and type that up in our notes in section D, and that is that the solution has 1 even digit. And since we have already established that square is even, that means that triangle and circle must be odd. So let's go ahead and cross out all of the evens for triangle and circle. And so basically what that means is that our solution is going to have the form of odd, even, odd. Okay, well that does it for this round. We did complete our 3 Turing tests. We're now moving into the phase where we'll be discussing how to construct a good second round proposal. So notice the first thing, or the first criteria card A, we didn't test, where we're going to be comparing it to the value 3. We already know that triangle's odd, so that helps us a little bit. And then we also did not test criteria card C, where we're comparing the first 2 digits. And finally, we did not test criteria card F, the ordering. So a couple of things to note. Based on previous puzzles that we've solved on this channel, one thing to note is that whenever you have this criteria card where you're comparing the first 2 digits and the ordering criteria card, the following occurs. So if you say that, let's just say that the solution is in an ascending order, meaning that triangle is small and then square gets bigger and circle gets bigger. So if that were the case, if it was an ascending solution, that would automatically mean that triangle is less than square, and that would make this card irrelevant. Similarly, if it was the other case where it's descending, where triangle is large and then square gets smaller and circle gets smaller, that's a case where the solution is descending. That would mean that triangle is larger than square, and again making this card irrelevant. So for that fact, we'll state that we're going to deduce that the solution has no order. Okay. And the following also, notice that in none of the 6 criteria cards do we see any kind of reference to circle. So somehow circle will have to be forced into one of these odd digits. Okay, so that said, how can we know that obviously there are no pairs, all digits have to be distinct. So somehow in choosing triangle and comparing it to square, our options should be limited so that, again, circle is forced into a value. So, and I think that I don't think triangle can be 1, because if that were the case, then obviously triangle would be smaller than square, and I don't think triangle can be 5, because that would mean that 5 would be greater than all of the digits under square. So I think triangle is going to be a 3. And then that said, we're going to choose, either 2 or 4, which that is now a toss-up. We know that it can't be equal since we're dealing with an odd triangle and an even square. So it's either going to go from 3 to 2 or 3 to 4. And because of the no order, we can't have a duplicate. So it's probably either going to be a 3, 4, 1 or a 3, 2, 5. And so let's go with 3, 4, 1 as our second round proposal. So the first thing I'm going to test is, let's go ahead and test the ordering. I'm going to say not the ordering, the comparison of triangle and square. So that's criteria card C. Okay, so it is incorrect. So it is not true that triangle is less than square. And as I stated, can't have them be equal. So that means that, in fact, triangle needs to be greater than square. So let's go ahead and type that up. And that is criteria card C. And that again is that triangle should be greater than square. Okay, so let's see, what can we cancel? So I don't think triangle can be a 1, since if triangle were 1, there wouldn't be anything smaller for square to be. And I think that might be it, because if square were 2, yeah, there's obviously some options that are larger, 3 and 5 for triangle. And even for 4, there's a 5 that's greater than it. So I think that's all we can cross out. And let's go ahead and test criteria card A. Okay, so in that case, yes, it is true that triangle is equal to 3. So let's go ahead and type that up in our notes. Oops. Yeah, triangle is equal to 3, and so that means yeah, we can cross out the 5. Okay, and because triangle needs to be bigger than square, that means that square has to be 2. So square can't be 4. And let's see what else. Now we did deduce that this solution has no order. Let's see. So if that were the case and there are no duplicates, then that would mean that, yes, circle should be 5 in order to accomplish that. Yeah. So let's go ahead and cross out the 1 and the 3, because you can't have any duplicates or pairs. So it looks like the solution is 3, 2, 5. Okay, let's go confirm. So 3, 2, 5. Okay, fantastic. And let's see how we did versus a Turing machine. So again, we were able to accomplish in a puzzle with 6 criteria cards to only question 5 of them. That's always a great indication that we should have beat the Turing machine. So in the first case, we did B, D, E, and B was incorrect, and then we did A, C, and C was incorrect. So let's go ahead and type that up. So first we did B, D, E, and then we did A, C, and I believe A was correct, but C was incorrect, and we skipped F. Okay, so fantastic. So we got, we beat the Turing Machine by one question. So again, the first round was great because we were able to establish kind of the structure of the solution of odd, even, odd, and then this sort of deduction where we were able to, figure out what the ordering should be based on the interaction between criteria card C and F was also very helpful because that eliminated the need to test it, saving us that one question. Well, what do you think? Had any information, thoughts in the comments? Give it a thumbs up if you liked it, and of course, to help other people find this channel, and of course, subscribe to not miss out on the next video. Well, until next time, have a great one.